Hello, and today's purpose of the day is I can make a scatter plot and write a line of best fit for the data. Also, I can determine proportional and non-proportional relationships. Let's review scatter plots. If we have a positive trend or a positive correlation, we are going to see data points that follow an upward trend. If we think of a negative correlation, those points are going to follow some type of downward trend. And if we have no correlation at all, our data points are going to be scattered throughout the graph in no particular order. Let's practice drawing a line of best fit. So to draw a line of best fit, we want to try to use as straight of edge as possible. And this line should be as close to as many points as possible, or go through as many points as possible. So if we look at the first one, this first graph, we can tell that it follows a positive correlation, so I'm going to draw my line of best fit in this graph. I tried to draw that line as straight as I could and go through as many points as I could. Let's look at the second example. We see here that there's no correlation, so we actually cannot draw a line of best fit because there is no correlation. Let's look at an example where we need to draw a line of best fit and write an equation for that line of best fit. So let's look at the question. The table shows the number of cases of foodborne botulism in the United States for the years 2001 to 2005. Part A, draw a scatter plot and determine what relationship, if any, exists in the data. Then write a complete sentence to describe its meaning in the situation. So let's take a look here. We're given a table of ordered pairs, years, and number of cases, and a graph about the U.S. foodborne botulism cases. So let's graph those following points on the graph over to the right. So I graphed the ordered pairs on the graph, and you can tell that it is going to be a negative correlation. So let's draw a line of best fit now. I drew in my line of best fit, so let's answer question A. So we know it's a negative correlation, so when we want to write a complete sentence, let's make sure we incorporate something like that. So I'm going to write, as the years go by, the number of U.S. foodborne botulism cases decreases. So this would obviously be a negative correlation. That would be the relationship. So we also figured out part B, draw a line of best fit for the scatter plot. So let's look at question C. Write the slope-intercept form of an equation for the line of fit. So here are the steps we are going to follow. Find the slope. Use points that are on the line or close to the line. Number 2, plug in the slope and the point. Number 3, write an equation in slope-intercept form. So from this graph here, I'm just going to use the points 2003 and 20 and 2004 and 16, because those are both, according to my line, pretty close to being on that line. So I'm going to write those down, and I'm going to put those right here. So 2003, 20 and 2004, 16, and let's find the slope. So that again is using y2 minus y1 over x2 minus x1, or simply change in y over change in x. And again, that triangle means change in. So I would say here y2, 16 minus 20 would be negative 4. 2004 minus 2003 would be 1. So that slope is negative 4. So let's plug in the point and the slope, and let's solve for the y-intercept. So here I'm going to do that. So I would say, I'll use this first point here, 20 equals negative 4 times 2003 plus b. And so here I would get 20 equals negative 8,012 plus b. Add 8,012 to both sides. And so I get 8,032 equals b. Now I have to remember, what did I scale the x-axis by? Well, that's in years of 2000, so I actually scaled it by 2000. So, here I'm going to go ahead and divide by 2000 because I scaled my graph. Most times graphs aren't scaled scaled by this much, so you don't even have to do anything when you solve for the y-intercept. But here, I needed to. So when I divide by 2,000, I end up getting 4.016. But then I also scaled my y-axis by 10, so you can see up here that it jumps up to 10, and I go from 10 to 20 to 30 to 40. So I actually have to take this answer here and multiply it by 10. So I move the decimal over 1. So really here the y-intercept, is about 40.16, according to how I scaled my graphs. And again, typically graphs aren't normally scaled, but this one, as you can tell, is on both axes. So then my final equation here, and I'll change colors, would be y equals negative 4x plus, I'm going to say, about 40. Now, if we look at our graph, does that look like it's about right? Well, we have a negative slope, so that does appear to be right. Negative 4 would be fairly accurate. And then look at the y-intercept. We're close here to about 40 or a little above 40, or it's somewhere very close to 40, which means our y-intercept was spot on, and that would be an accurate line of best fit for this scatter plot. Let's get a little bit of review with proportional and non-proportional relationships. So proportional relationships. If a relationship between the domain and range of a relation is linear, the relationship can be described by a linear equation. If the equation passes through 0, 0, and I'm going to highlight that, and is in the form of y equals kx, then the relationship is proportional. And so if you can recall, y equals kx, looks very similar to some other type of variation that we know, which is called direct variation. So the big idea with proportional relationships is that it goes through the point 0, 0. So here we're just going to read through this example. Suppose you purchased a number of packages of blank compact discs. If each package contains 3 compact discs, you would make a chart to show the relationship between the number of packages of compact discs and the number of discs purchased. Use X for the number of packages and Y for the number of compact discs. So here's the table that shows if you order 1 package, you receive 3 CDs. 2 packages, you receive 6 CDs, so on and so forth. So the difference in the X values is always going up by 1s. And the difference in the Y values is adding 3. Since the relation is also a function, we can write the equation in function notation as f of x equals 3x. This relation does include the point 0, 0 because if you buy 0 packages of compact discs, you will not have any CDs. Therefore, this relationship is proportional. So let's take a look closer and get a little bit of practice. Natural gas use is often measured in therms. The total amount a gas company will charge for natural gas is based on how much natural gas a household uses. The table shows the relationship between natural gas use and the total cost. So right below is a table, and you can tell that the X values are increasing by 1 and the Y values are increasing by 130 each time. So graph the data. What can you deduce from the pattern about the relationship between the number of therms used and the total cost? Well, I'm going to go ahead and graph this over at the right. For answering part A, we can confirm that this is a linear equation and it is proportional because it goes through the point 0, 0. So part B says write an equation to describe this relationship. I would write y equals 130 times x, where x is the therms used of gas. Use this equation to predict how much it will cost if a household uses 40 therms. Well, this would be y equals 130 times 40. And again, I'll write proportional under part A. And my answer here would be $52. So again, this was just practice on proportional relationships. Now let's take just a little bit of time to review non-proportional relationships. So if the ratio of the value of x to the value of y is different for select ordered pairs on the line, the equation is non-proportional. Also, if the graph of the function does not go through the point 0, 0, then you have a non-proportional relationship. So let's just take look at an example here of this graph and the table. So I have a graph and I see a table of pairs, and so we know just by looking at the graph that this is not proportional. It's non-proportional because it doesn't go through the point 0, 0. We also could try to write a function for the table of values, and we see that the x values are increasing by 1, and the y values are increasing by subtracting 2 each time. So we know we will have y, or f of x, equals negative 2x. And if that were our equation, that would be proportional because it would go through the point 0, 0. But if you look at what the y-intercept is here at the table, it's actually positive 2. So because we have that plus 2, that makes it non-proportional because it won't go through 0, 0. Here are a few more exercises if you would like to get additional practice with non-proportional relationships. You do not have to fill all of them in, but you certainly can if you would like to. Here are the final answers. Thanks for listening. Please see Schoology for more information. Have a great day. Bye.